Okay, so review of laws of logs and all the parentheses that pertain to what we should have learned, refined in Algebra 2, and definitely around pre-cal, okay? No worries. If you haven't refined it, it has to be cleaned up ASAP to have a chance at these derivatives. So I've just drawn natural log of x, and there's a lot that I want you to memorize just from this picture. Okay, one of them is, what's the natural log of 1? 0. Because this point is 1, 0. Okay, what's the natural log of 0? Undefined. That does not exist, but undefined because we're talking about the domain of natural log of x. And right there at x is equal to 0 is a vertical asymptote. Okay? What would be the third one that I'd want you to memorize? The natural log of e. And what is that? 1. Okay? So e is like here. It's approximately 2.71828, so on and so forth. And the y value right here is going to be y equals 1. Okay? The other things that are very important to know from natural log graphs is their domain. What's their domain? Anyway. X is greater than 0. You cannot take the log of a negative or the natural log of a negative number, nor can you take the log or natural log of 0. It almost feels like the square root function. The only difference is you can square root 0, but you can't natural log 0. Okay? Now let's talk about this. The best way to solve an exponential function, in my opinion, is to convert it first to a logarithmic function. Vice versa, if you're given a logarithmic function, the best way to solve it is to convert it to an exponential function. And there's a method, a reverse Hart method, that we can use to change those. For instance, if I had log base 2 of 8, does someone know what this equals? What does log base 2 of 8 equal? 3. Let's say you didn't know. But you know from this rule that the best way to solve a logarithmic is to rewrite it as an exponential. You could start from the base and do like a reverse Hart method. Okay? And you could rewrite this as 2 to the x is equal to 8. Okay? And by intuition and just quick number sense, you can see that that's going to be 3. So the log base 2 of 8 is 3. So it's all about the rewrite, for sure, between logarithmic and exponentials to help you solve them and whatnot. When I am multiplying inside of a log or natural log, it's the same as if I were to what? Add between two logs. That's multiplication is addition. If it was dividing, that's the same as what? Subtraction. Okay? And then this is the big one right here. The big one here is if you have a coefficient that is multiplying a natural log of an argument, that means whatever it is, that input, it's the same as moving it as a power that would look like this. Parentheses are so important though, because if I wrote it just like this, x to the a, I would be wrong. Because it has to be this perspective, okay? And you'll see what I'm talking about whenever we do the harder problems. So, the questions that I started off by asking were, are these 4 different or the same? And if so, which ones are the same, which ones are different? So I'll tell you right now, these two are equal. I know this seems like a sine squared or cosine squared or tangent squared, but nonetheless, these two are equal. Okay? The way that this is written right now, this third one with no parentheses is that.
So if you just had natural log of x squared, you'd assume it's like that?
Exactly. Look at this third one again. If I have this given to me, this is something that I need to know right now. Anything that follows the natural log, anything that's being multiplied, it's like I'm going to grab that entire piece and bring it in as an argument. Everything that's multiplied will be glued together as being in parentheses. Okay? So this would be in parentheses, and so would this. If I were to write natural log of x plus 5, you tell me, would this be the natural log of x plus 5? Or would it be the natural log of x plus 5? The first one. The first one. Because of this rule that I just said. Whatever follows the natural log, everything that's multiplied, that's going to be inside the parentheses.
So the third and fourth are the same.
So then third and fourth are the same.
Okay.
Because x squared is a form of multiplication. It's like x times x. We good?
Yeah.
Questions? They're subtle but huge and important, okay?
But the first two aren't equal to the next two.
So let me come back just a little bit. The way that it's written right here, just like Braden was saying, these two are the same. The most confusing part, and I know, and it's annoying, but all this is by hand. I just told you the first two are the same, the last two are the same, the way that they were originally written. But if you go to a calculator and you put that in, what this will actually compute is that.
Why?
Because that's the way the calculator was unfortunately programmed.
It's programmed wrong.
Okay? But the natural log of x, if you wrote it like this, with no parentheses, you're going to have a lot of these in the test. And this is what I'm trying to show you right now. You're going to ask the question, well, how do I look at that? Is this going to be like this? Or is this going to be like this? You know what I mean? You know, and I'm going to tell you, just do what we did in class. Okay? And that the biggest rule is this. Anything that follows the natural log that's multiplied, you're going to include it all in the argument. Okay? So if I were to give you something that looked like this. Natural log of xy squared plus 5, you would assume that everything after the natural log, whatever's multiplied together, is going to be in the argument. So if there were no parentheses, that's what you're supposed to interpret.
What if it was 2 natural log?
If it was like 2 natural log of all of this,
Yeah.
this is a good question. Good timing too. Because everything that follows the natural log, that's glued together through multiplication like a monomial, that's the way you're supposed to look at it. And the rule that we just looked at, the rule of a natural log of x is the same as natural log of x to the a. This is what you're going to do here. You're going to bring this to be a power of that inside argument.
And now you need more parentheses, right?
Perfect. Now you need more parentheses to show that that's where that 2 belongs. And then the 5 is just right there. Any questions so far? Okay, so the power of parentheses for sure. And then now to go to the rule of differentiation. Oh, before I do that, let's talk about a little bit more review of logs and exponents. If I have this, you said that x was what?
3.
3. And that was easy for you to do in your head. But what if I had that?
You would say the log base 2 of 9 equals x.
Perfect. Look at this. So I'm given exponential function. The best way to solve them that you're learning today is to rewrite them as a logarithmic function. So if I wrote log base 2, so the bases will always be the same as far as where they're going. So log base 2, and now think to yourself, 2 to the power of something will give you this argument value that's in the parentheses. So 2 to the power of x, so x goes over here, is going to equal 9. So a rewrite would be this. Okay? Now, furthermore, some people don't understand what I'm about to show you next, okay? And it's pretty important. If I have this, and I told you to cancel that, what would you do?
What do you mean cancel?
Exactly. So I'm going to take the square root, because I'm trying to take the square root. Otherwise, I'm doing the inverse function. Inverse. Give me another way to say inverse. Amy, what would you say instead of inverse? Multiplication, like inverse in general.
Like opposite.
Okay, so opposite, look, what's the opposite of this? -1. So that would add to what? 0. But what's the opposite of this? -1/2. It's still going to cancel to 0. You see what I'm doing? Why? Because I'm adding opposites to have a cancellation form of 0. So inverses is not the same as opposites. What word could it be the same as? Okay, so to me, what I'm trying to see, it's the backward process is what it is. It's not the reciprocal per se, it's the backward process. So if I square a number, what's the backward process? Square root the number.
Is it like a converse?
Yeah, you can look at it like that, yes. So the backward process, for sure. And with inverses, you're not canceling to 0. You're not canceling to 0. What are you canceling to? 1. Or x. Or 1x. You see what I'm saying? So, what is... And the things that you know right now is that x squared is this. And the square root of x function is that. So, a piece of the x squared and the square root, they reflect across y equals x because they're inverses of each other. Okay? So what if I have this, and I told you to solve for x? What could I do? Okay, so something a little bit different. Natural log both sides. What happens to these two things? They cancel to a form of what? 1. But remember that rule? And some people ask, well, what happens to the x? When they cancel, what happens? And I say it comes down as a coefficient. Because if you remember the rule, we can move it, right? And we know from our first slide that we started today that the natural log of e is what? 1. There's a lot to review today, a lot.
So that's just where the rule comes from.
That's where the rule comes from. Okay? Guys, what's another way of saying the natural log of something? Log base e. So if I have a natural log of x, it's the same as saying the log base e of x. Okay? So here's the thing that a lot of people don't know or never realized. You know how to cancel e. Take the natural log of both sides. What you just did was this, believe it or not. You took the natural log of both sides. So a log and an exponential function that have the same base, you with me, will cancel to a form of 1. And all you have is x left over. And natural log can also be written like this. I just wanted to show you from what I'm about to show you. But I don't want you writing log base e's. Please don't. Write them as natural logs. Throughout your work, yeah, write log base e if that helps. I don't think it would.
Just if you see E, just know to take natural log. Right?
Yep, perfect. But it's this one that people struggle with. How do I cancel the base of 2? Log base 2 of both sides. So these cancel to a form of 1, and I'm left with that. See, but a lot of people, that doesn't sit well with them. Okay? And this is why I tell them the best way to solve an exponential function is to rewrite it as what? As a logarithmic, where 2 is the base, 2 raised to the power of x is equal to 9. And notice, we still get the same exact answer, either way. I did a lot of review just now. Any questions before I continue? Because we haven't done any calculus yet. Are we good? Okay. So let's say that I had this written down. And I wanted you to take the derivative. Okay? First of all, what we've talked about today so far, parentheses are important. You tell me, where did the parentheses go? Where does it stop? Oh, the whole thing, right? Perfect. So if it takes the whole thing, this is what we should have right now. Okay? Any suggestions? If I told you not to take the derivative per se, but just to expand it for now. No calculus still. Just expand it.
Maybe do ln x plus ln squared of x squared plus 2.
I like what he's saying. Okay? Let's put some parentheses. Omar, where do the parentheses go? All we're doing is rewriting.
For the first one,
Where do I stop?
after the first place,
Yeah, right here, right? And then over here?
before the square and after the square.
Perfect. So that the final thing, can someone tell me, it's subtle, can someone tell me if this is correct? No, it's not. Because what we started today's notes, you need those parentheses right there. And if I continue to expand it, expanding means to bring the coefficient out front from one of the laws of logs. This would be the full expansion.
Isn't the 1/2? It comes out front, right? So it's natural log.
Right here. Yep.
Well, I'm just saying. I thought it stayed inside.
Stayed inside the argument?
Yeah. So because you have parentheses right now, right?
Yeah. So you think that the 1/2 comes right here?
Well, I'm not sure.
Okay. No. So remember this? It's the same as this.
Yeah. Okay.
So what we're doing, guys, we're going from this to that. Are we good? Okay, so real quick, as I continue going forward, I want you to log into WebAssign. I want you to find some questions, because we have some questions for a lot of bonus points. We're going to look at supplemental today for group bonus points. I want you to give me some questions from your WebAssign to help you out.
Just on part 1 or part 2?
Preferably the natural log and the exponential ones. Okay? While you're looking for that, I'm going to break it down what the derivative rules are for exponential and what they are for logarithmic. Okay, here we go. Exponential. Guys, is this exponential? No, this is called what? This is a power function. And that's why we use power rule. Exponential is when the variable is in the power. And the rule when you have a variable in the power is this. The carbon copy times the natural log of the base times the derivative of the power, which in this case is just 1. Okay? So that you understand, like with all letters, this is what I gave you in notes, like through text. I put 2 to the u, because it doesn't have to be x. It could be 2x squared, it could be 4x cubed. So it's the carbon copy times the natural log of the base times the derivative of the power. There is your rule for all exponential functions. Logarithmic, okay? You know that the rule is the 1 over the stuff times the derivative of the stuff. This is the rule of differentiation for natural log of something. But that's when the base is what? E. That's when the base is E. This is when the base is E. Are we good? It's just 1 over the stuff times the derivative of stuff. When the base is something other than E, this is whenever it changes. Now, the fancy calculators that we have, right? You can press this key right here, and there's a log button right there, that when you punch it, it will pop up this thing right here. And let's say that this is the log of 2, and let's say that this is 8. We know that's 3. Okay? And we know that's 3 again because of the reverse Hart method. We went and said, well, let's say it's equal to x. So 2 to the power of x, because the best way to solve a logarithmic is to change it to exponential, x has to be 3. But our old calculators in the past didn't do this, and it wouldn't calculate logs like this. Logs were calculated like this. If I had a log base A of b, we had to put it in our old prehistoric TI-83s as the natural log of b over the natural log of a. This is something huge that I want you to learn, even though it's old stuff, because it will help you memorize the rule of differentiation for all of the logs. The base is not e. Okay? So, I'm going to show you that here in just a bit.
It goes from like log base A to natural log, right?
Yeah, so that's a big thing. Log will change to natural log. So guys, my original one would be the same as if I were to make it into a fraction and do the natural log. So that's this blue E. So control e to the x. And it would be the natural log of what? Help me out.
8.
8 over what?
Natural log of 2.
Natural log of 2. So this is what we had to do with the older calculators. So control e to the x, and we'll put 2. And when I press enter, it gives you 3 again. So again, please memorize this rule as far as that change of base formula, basically. Natural log of a of b is the same, log base a of b is the same as natural log of b divided by natural log of a. And the reason why I want to show you this is for the following reason. If I have something that looks like log base 2 of 5x squared, and I asked you to derive this, it's going to be different. It's going to be different than just 1 over the stuff times the derivative of the stuff. Okay? This can be rewritten as the natural log of 5x squared over the natural log of 2. You with me? And now, can someone tell me what is the constant that you see in that fraction that I just boxed? What is the constant that I can pull out? What's the constant? Don't be shy. There is a constant that I could factor out.
From both the top and the bottom.
Well, not from both. Don't think GCF. Just think constant multiple rule. It's not the 5. It's the natural log of 2. So check this out. Do y'all agree that what I just wrote over there in that blue box is the same as that? Can y'all see that? And now look, is this a constant? No. Why? Because it has an x. It's variegated. It's waiting for an input. But is this a constant? All of that is a constant. And I can pull all of that out like I just did, like factored it out. You see what I'm saying? Because a constant that can be pulled out can also be multiplied back in. So if I took this and I brought it in, wouldn't it be the same as what I originally had in the blue box with understood ones on top and bottom? Yeah. So my method to show you this is to pull out that constant. Pull it out. Like that 1 over that piece. And then just take the derivative of this like normal. Just take the derivative. 1 over the stuff times the derivative of the stuff. Right? And then what will I do here at the end? I will constant multiple rule this back in. This is the derivative. For logarithmic functions, where the base is something other than e. Basically, it's something other than natural log. Because natural log is the easiest one. 1 over stuff times the derivative of stuff. 1 over stuff times the derivative of stuff. But logs that are bases other than e, where it has a log, it could be 10, it could be 2, it could be 8. You're going to have this rule. 1 over the stuff times the derivative of stuff, but times 1 over the natural log of the base. Otherwise, constant multiple rule it out. And instead of memorizing one more rule, I just keep it as the same as logarithmic, natural logarithmic, but not GCF, but factor out that constant multiple. Are we good? Okay. So, what questions would y'all like to warm up with before we do group bonus points from your homework?
Shouldn't it be, we can't use the
come up here?
Isn't there like a
Shade what you're talking about.
like here shouldn't be
Shade.
this?
So you're talking about that.
Like this times this plus.
Oh, okay. He's asking if I should product rule it from here.
Yeah, product
No product rule. Because remember, this original thing wasn't a product. Like, I know what you're saying. You see what I'm... That's a good question. He's saying, shouldn't you have done the product rule if the original one was a product like this? Well, here's the thing. If you did the product rule, your first, with me, times the derivative of the second is this. All of this. But then if I do plus the second times the derivative of the first, y'all all tell me, what's the derivative of the first? 0. Because the derivative of a constant is 0, so it would zero that out.
Isn't it just constant multiple?
Yeah, that's what I'm saying. So he's trying to look at it like product rule, which I'm telling them it's easier to look at like constant multiple rule. And I told you this from the very beginning of school, that constant multiple rule will make a lot of things so much easier. Okay? Otherwise, you're going to have a lot of work in parentheses. Okay, so I have a question for you guys. Let's go with so we will do x squared plus 1 over x minus 5. All of this is going to be square rooted. And we're going to take the natural log of this. Yeah. And this, we're going to set as my function, and we're about to derive. Okay. First of all, what's the rule of differentiation? Ryan, what do you see as the rule of differentiation for what you see right now in red? How would you approach that? Okay, so what do I write? Natural log of
The square root of x squared plus 1, and then minus the natural log of the square root of 1 over x plus 5. Oh no, it's just x minus 5.
yep is equal to y. Perfect. Has she derived yet? No. So each time on your quizzes and tests, I want you to make sure that you are writing what the function is, so that you and I know when derived or differentiation happened.
When you do derive it, would you put 0 for y or dy dx?
You would put dy dx, unless it says implicit differentiation. Okay. Okay, from here, so what I'm trying to do right now is I'm trying to expose you on how other people see things. Because that's going to strengthen you a lot right now. Okay? You have to experience what other people see to build your own knowledge, but also see the small little details with parentheses and stuff. Okay? So Jordy, what would you do from here? Because all we've done is a rewrite so far, right? Okay, so she's saying, real quick, let's do it with her. She's saying all of this is technically raised to the 1/2, and she's correct. Okay, let me do this with the other one that you mentioned. And right now, she's correct. But with other problems that are coming, if she doesn't write what, Taylor? If she doesn't write parentheses, I'm not saying you would, but she might miss the other ones. So these parentheses are important too. Because now the power of the argument can be rewritten, like Jordy was about to say, to this. But I do need parentheses still, right? Where are the parentheses that I need? I need them here, ending where? X plus 1, right? From what we were doing, from what we've been doing, this problem. And when will these parentheses end? After the negative 5, or minus 5. So now, just like Braden was saying earlier, ready? Omar, I'm going to treat this as a constant. So let's put it over here next to the door, and we're not even going to look at it for a little bit. And we're just going to take the derivative of that. What's the derivative of that, Omar?
1 over x squared plus 1 times 2x.
Perfect? But because of constant multiple rule, what do?
Times 1 half.
Times 1/2. I bring it back, and I multiply it back in. Okay? We good? Nate, what's the derivative over here of the second piece?
It's 1/2 times 1 over x minus 5 times,
Mm-hmm.
sorry,
1 over the stuff times the derivative of the stuff.
so, just,
What's the derivative of the original stuff?
1.
1. Cool. And what's the only thing that's wrong right now? Anyone? Parentheses where?
Around top.
1/2 after the 1. And then
No, oh, that's good. It's subtle, but I just want to make sure that I'm showing you right off the bat so that you don't miss points on the test and whatnot. Is what? Y prime or dy dx. Because I want you to show that, especially when we do bonus points today, so that you know when you've derived. And you knew when you were just applying laws of logs.
Do you really need that one though? That one is
No, so let's simplify it. Okay, so you're going to get bonus points for simplification and group bonus points today. I see this too. I see this too. So that my final reduced answer would look something like now. You tell me, Amy, is this correct? Don't say anything to anyone else yet. But Amy, is that correct? That's probably it, right? Where? Find it.
X squared, like the terms.
Not on x squared plus 1.
Distributing of the signs with the multiple.
after the 2.
Right here.
Come on, Christian, you're not 8. I thought that was done.
So 2 times this bottom piece, and if you wanted to write 2x minus 10, you could write 2x minus 10. So someone asked it earlier today. There's a couple still left. We're trying to help them out. Can you cancel those two?
No, you cannot.
No, why not?
You put an x out of the bottom.
Because it's not multiplication, right? You can't. You can only cancel between multiplicative pieces.
Can you write what?
That's the crazy word.
No. Wait. Finish that sentence. Unless what?
You could change it into x over x squared plus x over 1.
Ooh, that's a good mistake. Look, so this is common, but I need to bring it up. It's a good one to make. Some people think
Oh wait, no, you can't. That's for the numerator, not a denominator.
that those are the same. But what they're failing to recognize is that you can only do this when you have how many terms in the what?
Denominator 1.
One term in the denominator. So if this was like this, then you could break it up into 2 fractions and then simplify it out. That's not what we have here. We have 2 terms in the denominator. Yes?
So, but if you had like x squared plus 1 on the top, then you could do x squared over x squared plus 1 plus 1 over x squared plus 1.
Whoa, dude. Whoa, sorry. Can you say that again?
So
And
if
come
you
up,
had
come
x-
up here. Actually,
okay.
come up here. I want to hear what you're saying, because it sounds like a good question. Go for it.
So if you had x squared plus
do that.
Okay.
You could do that.
But wouldn't x squared plus 1 over x squared plus 1 just go to
Yeah, the whole thing would just go to 1.
But then doesn't that not go to 1?
It does, but with algebraic manipulation.
1? Okay.
I have a question on the previous one.
Show me, come on. Are you talking about here?
Yeah.
Okay, what about that?
Is this the most simplified form of this one for
Okay, so for bonus points, I'm going to say no parentheses. So
it's-
yeah,
So 2x squared.
yeah. On the test as well, no parentheses. Unless it's like sine, cosine, and trigonometric functions that have parentheses, or natural logs that have parentheses, you know what I'm talking about.
Do you have to write dy over dx, or can you write y prime?
You can write y prime. This is a good question. But I prefer dy dx because of what's coming next unit. So this is what I want you to do. If it would be easier for you just to write y prime everywhere, and then at the very, very end, change y prime to dy dx, do that. But no matter what, I want you to get used to dy dx because of what's coming next unit. Okay? It's in my opinion, one of the most difficult parts of calculus because it's a lot real fast. And it's like with physics-based problems and so on and so forth. Now let's do another example. Now let's do one from the book that you guys, or from the WebAssign. Anyone have a good example?
Taylor, didn't you have one?
It was for a different, it was for the other one.
Okay.
Wait, that was in this website.
Part 2, question number 7.
Okay, part 2, question number 7. What does it say, Omar?
It's like a several mark question. Should I?
So part 2 from number 7.
Should I show it?
I don't understand what your question is. Oh, so this isn't the homework though that I'm talking about. I'm talking about the homework that is natural log or exponential.
That's from part one.
It's from part 1, okay? Okay, got you. So from part 1, we're only talking about part 1 questions for now. And then I'll do part 2 questions on the other video.
Here.
Number 4? Alright, Amy, what does it say?
Do you wanna look at it?
So number 4 is just, you are not deriving anything. You're just trying to combine using laws of logs all of the pieces that you're given into one huge combined log or natural log equation.
Is that 1/3 times 5?
So it's 1/3 parentheses all of that. So what I see immediately, check this out. I'm going to move this 5 as a power here and put parentheses right there. Okay? So I have basically all of that, but now I'm going to just make that power of 5. Okay, so this 5 will end up going here, and it was multiplied. Okay, this 1/3, actually, you tell me, because some of you are going to do things differently. What could I do from this step? Because right now, this is 1/3 times all of this.
Can we work the inside first?
You can work the inside, yeah, for sure. Because you have addition between 2. What will these 2 arguments do with each other? They will multiply. So we're going to do x plus 4 to the 5th times x.
And then all over.
And then all over, we're dividing the x squared minus 8. All of this is the natural log. And we're still multiplying 1/3 by all of that. So what could I do? Still gotta
Put
bring
the
it.
1/3 to the.
I could bring 1/3 as the power, and it's almost done. But I need to do what? Put a big parentheses to include that 1/3. Okay? What if I have an answer that looks like this, and I multiply it with this? You tell me. Do you think I want you to write it like this? Or to write it like this? Or does it not matter?
I think it does.
Which one do you think, Omar?
Second.
The second one. Because if I wrote it like this one, remember what I told you. Anything that follows a natural log that is multiplied, the way this is written up here would be the same as that. You're with me? So that's what I want to make sure that you understand, because this right here is the same as x times natural log, right? Which, what's the last way that I could write the correct answer from what we've talked about today? Because we've talked about a lot. Yes, Jody?
You would put the extra parentheses and put variables. Like raise the 2 to the power of x.
Yeah, 2 to the power of x, like that.
I thought.
That's these three. So this one is the same as this,
Oh, yeah.
is the same as this. But this one is the outlier that's not the same, because it would be natural log of 2x. Cool? Because there's a lot of small little parentheses that's going to hurt you if you're not understanding where parentheses belong and so on and so forth. Alright, let's do another example. Let's do one that is the derivative. Okay? That one's a good one. Can you read it, please?
F of x equals 1/2 times x, the natural log of x to the 4th, at negative 1, 0.
And do they have these on the original problem?
No.
So they have, look at this, guys. They have this written as a problem. This is where we have to know our stuff. We have to master it, not just, I think it's this. Okay? The way this is written right now in the calculator would be like that. You with me? But the way you should interpret it, because of what we said today, is like that. Power of parentheses. You're going to hear me say that all year. This is your first. This is your last. Or your second. Because we're about to do what rule? The product.
Would you not bring the 1/2 x to the as an exponent?
So if I did that,
Oh, it gets raised to it.
it gets
So
raised to
just
it.
be 2x.
Do you see what's happening right now, guys? Some of you are going to try stuff, and I want you to. And I want you to understand what works, what doesn't, when and where, and why it doesn't. Right now, what Braden suggested, is this legal, what I just did?
Yeah.
Yeah. I mean mathematically appropriate. Yeah. So, this is the same as multiplying and getting this. Do you all agree? If I did it like that.
And then you just bring it back out, I guess.
And then you could do 1 over the stuff times the derivative of the stuff. But do you know the derivative?
Well, that's why I was saying bring 2x out after.
Oh, and then bringing it back out? I mean, you can. That's fine.
Yeah.
Do you see what he's doing? He's trying out the algebraic manipulation. That would be the same as like bringing the 4 out over here. and just having 2x.
So is that any different though? If you have the 2x, if you bring the 2x out, and then for constant multiple you take it away in front of the derivative, just
No, slow down. You said if I bring the 2x out, I cannot, what constant multiple were you going to bring out?
Oh wait, we haven't even started finding the derivative yet. Okay.
Oh, yeah. Okay? Alright, so my suggestion to you is, yes, you could bring it out like this, but ultimately you're still kind of doing the same thing. You're still trying to do a product rule of some kind. Okay? So, here we go. The first times the derivative of the second. Jordy, what's the derivative of the second? Yep, 4x to the third. Do you all agree with that? We good? So 1 over the stuff times the derivative of the stuff. Plus the second times the derivative of the first. What's the derivative of the first anyway? Just 1/2. What is this simplified to? You should be getting faster with simplification. What is this simplified to? 4 over x. So 4 over x times x over 2, right? What would that all simplify to? 2. So you don't need that parentheses. And then it's plus the natural log of x to the 4th times 1/2. It's the same as 1/2 times this, which is the same as natural log of x to the 4th to the 1/2, big parentheses, which is the same as the natural log of x squared. So 2 plus the natural log of x squared is my derivative function. And yes, I need you doing it just like limits, and I will hold you accountable for this on the test because we're going to do this all unit so that I know you know when you derive. And then now, what am I going to plug into this equation? -1 for x. We're going to do bonus points after this. So if I plugged in a -1 and I squared it, what's the natural log of a positive 1? 0. So the slope is 2. Bless you. So y minus y1 equals the derivative times x minus x1, 2x plus 2. Or 2 parentheses x plus 1. We good?
Great.
Alright, so that was review of logs, review of exponents, finding the derivatives of exponents, and the derivatives of logs with homework-based problems.